Problem 55. We have if x and y are real numbers such that x is greater than 1 and y is less than -1, then which of the following inequalities must be true? So a couple ways you could approach this problem. Let's write down the information we're given. Let's make sure we know what it means. So we have x is greater than 1 and y is less than -1. So if we remember our number line, if this is 0, this is 1, this is -1, we'll call this like -5 out here and this 5 out here. That means, we'll put our 2 in there too, and -2. That means that x, we have our open circle because it's not greater than or equal to, so it's an open circle. It's always going to be greater than 1. This is x. And then y is always going to be open circle because it's not equal to, so it doesn't include -1, is going to be less than -1. So our y is less than -1, or our x is greater than 1. Okay? So then the best thing to do is just to evaluate these inequalities. If you see one that jumps out at you, maybe check that one first, but otherwise the best process is just to check whether they are true, because only one of them has to be true because there's only one correct answer, right? So we can check, is x divided by y going to be greater than 1? We can easily see it's not, because you can pick any value. So let's say x is 2, because 2 is greater than 1. So let's say x equals 2. We're checking A here. And then y, let's just say it's some negative number, right? Because y has to be a negative number, right? Because y is less than -1. So that's going to be all the numbers over here, which are all negative. Let's say it's a -5, for example, okay? So then our equation is going to result in 2 over -5, just directly substituting those in. We have x over y, so it's 2, our x value, over -5, our y value, is greater than 1. We're evaluating this to see if it's true. Now, 2 over -5 is the same thing as -2 over 5. So can that be greater than 1? No, because this is a negative number, right? So no matter what's over here, it's going to be a negative. Moreover, it doesn't matter what numbers we pick, because x is always going to be a positive number and y is always a negative number. So it doesn't matter what values you pick. When we divide a positive by a negative, we're always going to get a negative number. So there's going to be some negative number, and that can never be greater than 1. So it can't be A. Let's check B. So we have the absolute value of x squared. Is that greater than the positive value, or the absolute value of y? It looks like it might be able to. All we need to do to disprove it, though, is find one case where it's not true. So for example, let's pick a super small value for x, like 2 again. X equals 2. And let's pick a giant value for y, like a super big value. Like how about, let's go with, I guess it's a super small value. Its magnitude is going to be super big. Or its value is going to be super big. Its absolute value is going to be super big. So let's pick like -1 million. Okay? So then our equation is going to be 2 squared, the absolute value of 2 squared, is that greater than the absolute value of 1 million? We know it can't be, because 4 is not going to be greater than 1 million. This is -1 million, right? But the absolute value, if you haven't seen these before, this is the absolute value bars. So an absolute value, what it does, so if it's absolute value of -2, it just takes the distance from 0, which is 2. So the absolute value of -2 is going to be 2. So it basically just turns negative numbers into positive numbers, essentially. And positive numbers get left alone because they're already 2 away. So then the absolute value of this is going to equal 2, or 4, because this is just 2. And 2 squared is 4. Is that greater than the absolute value of a -1 million, which is just going to be positive 1 million? No, of course it's not. So it can't be this one either. Let's check C. We have x over 3 minus 5. Is that greater than y minus 3 over 5? So remember, we have a negative number here. So let's say we pick some number. Let's pick different numbers than before. Let's say x equals 3, because that's going to give us a nice equation. And let's say for y, it's, how about -6, just to make it a different magnitude than x. So then for our equation, forgot that arrow. So for our equation, we'll have 3 over 3 minus 5. Is that going to be greater than y, which is -6 over 3 minus 5? When we simplify, we see 3 over 3 is 1 minus 5. So that has to be greater than -2, because -6 over 3 is -2 minus 5. And then simplifying further, 1 minus 5 is -4. Is that greater than -7? Okay, we see that it is, but are we done? We're not sure, because we have one example that's true, but if any one example is false, that will prove the entire statement false. So let's think about it more. The other thing you could do at this point, you have two options. You could check these to see if you can find counterexamples, because we haven't checked them yet. And if you can, then it has to be C. Because if these have counterexamples, and also A and B did already, then that means that C has to be true, because the other ones are false. And there's only one correct answer. But if you can reason with yourself and figure out why this is always true, and maybe write a proof for it, then that'd be the case. We're not going to write a proof for this specific example because I feel like the logic is pretty consistent. So let's think about it. No matter what value we pick for x is going to be a positive value, because x is always on this side of the 1 on the number line. So x equals, we'll write this for C. Actually, we'll write it up here. X equals a positive number. Meanwhile, y equals a negative number, okay? So now we have a positive divided by a positive, okay? And the smallest that number can possibly be is going to be -4/3, roughly, because x is slightly greater than 1. So let's say x equals 1.0001, right? Because they don't have to be integers. They're real numbers. And then let's say y is as close as you can get to. So let's say y is -1.0001. So just on the other side of this circle. Same thing, just on the other side. It'd be like right here and like right here, like right on the edge. Then our equation is going to be roughly 1/3, okay, minus 5. And is that greater than -1/3 minus 5? And we can see that's always going to be true because we have -4 2/3, which is when you put this in your calculator, get that. -4 2/3. Is that greater than our value of -5 1/3? And we can see that that's always going to be the case. And that's because our x value is more positive than our y value always. So when we take them divided by some constant that's the same, 3, and then subtract the same number, 5, that is always going to be true because x is more positive than y. So by definition, it has to be C.